Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst powers petabyte-scale SQL analytics fast, at a fraction of the cost of traditional methods, so that you can meet all of your data needs, ranging from AI to data applications to complete analytics. Trusted by teams of all sizes, including Comcast and DoorDash, Starburst is a data lake analytics platform that delivers the adaptability and flexibility a Lakehouse ecosystem promises. And Starburst does all of this on an open architecture, with first-class support for Apache Iceberg, Delta Lake, and Hoodie, so you always maintain ownership of your data. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst and get $500 in credits to try Starburst Galaxy today, the easiest and fastest way to get started using Trino. Dagster offers a new approach to building and running data platforms and data pipelines. It is an open-source, cloud-native orchestrator for the whole development lifecycle, with integrated lineage and observability, a declarative programming model, and best-in-class testability. Your team can get up and running in minutes thanks to Dagster Cloud, an enterprise-class hosted solution that offers serverless and hybrid deployments, enhanced security, and on-demand ephemeral test deployments. Go to dataengineeringpodcast.com/Dagster today to get started, and your first 30 days are free. Your host is Tobias Macey, and today I'm interviewing Alex Merced about Nessie, a git-like versioned catalog for data lakes using Apache Iceberg. So, Alex, can you start by introducing yourself?
Hey everybody, my name is Alex Merced. I'm a developer advocate for Dremio. So for the last several years, I've been talking about data lakehouses, about open source technologies like Apache Iceberg, Apache Arrow, Nessie, which will be something I'm going to love to talk about today, but all about the lakehouse, even so much being one of the co-authors of Apache Iceberg, the definitive guide, an upcoming book from O'Reilly.
And do you remember how you first got started working in data?
It's a fun story. I have a very long, not traditional way I kind of got here. So the long and short of it is basically, and then definitely I have a longer version of the story in places. But basically, I did start off as a computer science major, but then I got really into music and kind of went into this completely different category of studying like culture, marketing, and which somehow led me into a career of training people in finance. And I ended up training people in finance for 10 years. So I spent a lot of time breaking down really complex ideas and helping people kind of understand them in a more accessible way. But I then eventually ended up back in software and came back as a software developer and did that for a few years and also trained software developers. But I was always a big fan of working with databases. So like some of my favorite projects were finding ways to optimize a database, finding ways to offload workloads from and business logic from the wrong places when people put like maybe too much of that stuff in the client side of their websites. So I started kind of gravitating more and more toward the data space. And then I also started gravitating more towards like a DevRel, dev advocacy, because I was always naturally someone who would like to teach. I like to create content. I like to break down ideas. So I decided to make the shift from software development into the DevRel, dev advocacy world. And I ended up finding a home in Dremio where I got to spend a lot of time learning about this really cool, exciting thing called the Data Lakehouse. And that's definitely makes me wake up really excited every day. And now I get to help people understand that and bring that understanding in how not only what it is, but how to implement it, the technologies around it, and so forth.
And for the conversation today, we're focused on the Nessie project, and I'm wondering if you can describe a bit about what it is, some of the story behind it, and where it fits in that context of the data lakehouse.
Got it. Okay, so bottom line is the Nessie project at its core is a catalog. So when it comes to like the Apache Iceberg table format, there is a need for a mechanism to act as a catalog. So it tracks all the different tables, and primarily what it does, it tracks a reference to what is the most current metadata.json file for that particular table. So at the core, that's what Nessie does. But Nessie provides this additional ability to actually create commits, not at the individual table level, but at the catalog level. So it actually, every time that those catalog references changes, it basically treats it like a commit, which means it allows you to have the same sort of git-like semantics as Git, as far as being able to do branching, tagging, and this kind of changes the dynamics of sort of how you interact with your catalog and how you plan sort of like data ops type practices where you want to kind of isolate developer environments or roll back when it comes to disaster recovery. It changes a lot of things and actually makes it oftentimes easier and creates sort of new patterns when it comes to the data lakehouse.
You mentioned the ability to do branching and committing and merging and tagging, and I'm wondering, in terms of the context of data lakehouses, the overall data pipelining and workflows, What are some of the core problems and complexities that Nessie is designed to solve for?
I mean, bottom line, like a couple different situations where Nessie becomes really useful is probably the lowest hanging fruit is like data rollback. So basically, you have maybe a pipeline that fails, and now you have bad data or partial or inconsistent data in let's say a handful dozen tables. Now you technically can roll back those tables directly from the table format in Apache Iceberg, but you have to do each table one by one. By having a catalog level abstraction, I can just roll back the catalog to the commit that was like the last clean commit, and I can do that in one fell swoop and move the whole catalog back to before that ingestion job. But also, what happens a lot of times is that people would create duplicates of their data, like for a developer environment, and then they would do all their work there, and then have to merge those environments, and it was harder to create these environments and too more costly because of the storage. But with versioning like Nessie, I can basically create that isolated branch environment without creating a single duplicate of my existing data. It would just basically isolate the new snapshots going forward, which would the only new data is really the new data of those new transactions.
In terms of my experience of surveying the overall data ecosystem, in particular the data lake and data lakehouse environments, the closest thing that I've seen to Nessie as far as this branching and merging semantics, the ability to do that kind of zero copy cloning, I guess there are two pieces to that. One is the zero copy cloning and being able to do very low cost developer environments, copy on write semantics is with Snowflake. I know that they have the ability to do that kind of snapshot tables, create a copy of a table using the same existing underlying data. But from the Lake perspective, the closest project I've seen is Lakehouse, which has that same idea of Git semantics, but at the S3 abstraction layer. And I'm wondering if you can talk to some of the overlap and some of the divergence between Nessie and Lakehouse and when you might decide to use one versus the other.
Oh yes. I find the differences quite interesting. And the funny thing is, like, I think they were both sort of kind of coming into existence around the same time. I recently saw a talk where they talked about sort of the evolution of Lakehouse, and I remember seeing a talk about the evolution of Nessie. And those initial questions were the same. And both of them started like basically asking questions: can we just use Git? And realizing, okay, like the type of throughput, the type of the amount of changing that happens in data is not going to Git's not really built for that. So basically, you have to kind of find some other abstraction. So Lakehouse went the approach of where you basically capture sort of deltas in the actual files. So you say, okay, add this file, subtract this file, while Nessie goes through the approach of just capturing sort of that metadata change. So a couple ways to kind of think about it is, imagine I updated an Iceberg table with the insert. That might create 1,000 new files. So in the case of the Lakehouse commit, it's not aware of the table. So it's not aware sort of that a table exists. It's just aware there's 1,000 new files in my file system, and then captures a commit that says, okay, hey, these 1,000 files have been added. While Nessie, the only thing that changes in the Nessie is one thing. It changes there's a new metadata.json file. So instead of tracking 1,000 new things and saying 1,000 new things were added, it's just, hey, this table snapshot has changed from pointing to here to there. So it's a much more sort of lightweight change that can handle sort of very high velocity throughput, as far as like if you're making a lot of changes at a time, because you're not tracking as many different items. But it's also a couple other differences are that it's sort of more table aware because it is at the catalog level, which allows you to sort of move all of those git-like semantics into SQL. So I can create a branch using SQL. I can merge a branch using SQL. I can create a tag. While with Lakehouse is usually it's mostly done through the file path. So basically what it does, it takes advantage of object storage and says, okay, hey, there's going to be this dynamic part of the file path that represents which branch you're on. And then oftentimes you create these branches. Oftentimes all of the work has to be done with the CLI. So while probably like for a lot less technical users, SQL is going to be a much more accessible approach to doing a lot of these things. And the CLI tool might be maybe a little less accessible. So there's some ergonomic differences, I would say.
Zeroing in on that catalog element, we've mentioned a few times that Nessie is a catalog and it corresponds to various pointers into the Iceberg table format. And I'm wondering if we can dig a bit more into the context of what purpose does the catalog serve in that data lake, data lakehouse environment, and what are some of the alternatives, or what are some of the pieces that Nessie might replace if somebody already has an existing lakehouse environment?
So a couple of things first, so right now, Nessie primarily works with Iceberg. The cool thing about Nessie's architecture is that it just tracks sort of these like little metadata objects. So basically, it's really just an object. It has like a data type. And right now, the main data types you see are Iceberg tables, Iceberg views. Theoretically, other table formats could come into the picture pretty easily. but basically tracks that metadata. Now, the thing is that the way the Iceberg spec works is that generally that catalog reference is sort of like your source of truth when it comes to the current state of the table. So the problem is you generally don't want your Iceberg references in more than one catalog. So this is where basically, hey, if I choose Nessie as my catalog, then that precludes me from using another catalog like an AWS Glue or a Tabular or something like that. So oftentimes when you are adopting an Apache Iceberg Lakehouse, you do have to take a look at sort of like what are the tools you're using and what are the different features of the different catalogs. Most of them are going to generally provide you the main service of basically, hey, I can identify my tables, and now I can take this catalog to Spark sees all my tables. I take this catalog to Flink, it sees all my tables. I take it to Dremio, it sees all my tables. But not every catalog works with every tool currently. I think that story's gotten a lot better. So most catalogs are workable in most places nowadays. But that is essentially sort of one of the big sort of cost benefit calculations you have to make when selecting a catalog. And when it comes to particularly with like Nessie, it works with pretty much all the typical open source tools. So it works with Trino, it works with Presto, it works with Dremio, it works with Apache Spark, it works with Apache Flink. So you get that branching and merging across all these tools. So if your workflows incorporate these tools, you can then add that branching level, merging tagging to it.
And now digging into the versioning capabilities specifically, you mentioned that at a high level, what Nessie does is it keeps a reference to all of the table metadata pointers so that within each set of transactions or each commit, you can say, I am pointing at this set of metadata for all of these tables. And so you can have commit and rollback functionality across tables, across transaction levels. And in terms of the actual versioning of the data, I know that Iceberg has built-in support for being able to do optimistic concurrency control and being able to keep snapshots to different points in time of data based on the underlying files and the changes there. I also know that it requires a certain amount of maintenance to keep the tables kind of happy and performant as far as doing things like vacuuming and pruning old references and old versions there. I'm curious if you can talk to some of the ways that Nessie handles the interoperability with the versioning in Iceberg, as well as any of the maintenance pieces that it can help with as far as like pruning old versions, running table compactions, etc.
Yes. Okay. So basically, the architecture of like Nessie is that mainly it's basically going to be a running service that you would run. You could also get it as part of it's actually integrated into Dremio's its integrated catalog, but essentially it interacts through a REST API. And when it comes to the versioning aspects, right now, if I were to capture a commit, basically it creates this sort of like JSON-like entry in the backing store. So it could be like a RocksDB, a Postgres, whatever you choose as your backing store. That'll say basically I have a timestamp for that commit, sort of like the parent commit to that. So that way it knows what the sort of the tree looks like. And then just a couple other metadata pieces. So right now it's like a very small metadata imprint. So right now its ability to like generally, the best practice is oftentimes like one branch at a time. And there's actually, I'll give you a couple of examples of people who are actually doing that in production in that way. But when it comes to the maintenance side, this is where it gets a little bit tricky, because typically when it comes to Iceberg, when you're doing like expire snapshots or something like that, the assumption is that there's only essentially that like that table's metadata is aware of all of its own snapshots, which then that sort of with Nessie, you might have different branches where there's different versions of the metadata.json that has references to different snapshots for it to be aware of like, okay, hey, when I expire the snapshot, how do I know which files I can safely delete? So what Nessie did is they created their own tool called the GC cleaner, which does that kind of garbage cleanup. So it'll actually take a look at the metadata JSON at the head of each sort of branch and be able to kind of safely identify, hey, which files are able to be deleted. So when you run the vacuum command or either when you run the GC cleaner independently, or if you're using Dremio, you use the vacuum command, it'll use that tool to then safely make sure it deletes the right data files that are without affecting other branches.
Now, as far as the versioning pieces, anybody who's used Git for any length of time has dealt with the dreaded merge conflict. And when you're dealing with numerous tables, potentially dozens or hundreds, the last thing that you want to think about is how do I deal with a merge conflict if I'm creating a branch and then I need to merge it back after somebody else has created their own branch and merged it ahead of mine. And I'm curious if you can talk to some of the ways that those versioning changes, branching and merging are kind of sanitized so that we don't have to deal with these big, complex, messy merges in the event that underlying data has changed in a manner that is incompatible across branches.
Yeah, I mean, right now it is pretty shallow, so it's just tracking basically that metadata reference and essentially a timestamp and a parent. So right now you can get a merge conflict pretty easily if you're starting like several branches at the same time. Typically, the pattern we've been seeing is that what people they'll do is they'll start a branch at the beginning of the day. So what they'll do is they'll create a branch for that day, and then they'll do all their ingestion for that day on that branch, run some validating logic at the end of the day, and then basically merge that branch at the end. So instead of creating like lots of branches, for at least for ingestion purposes, usually you want to stick to sort of like one branch per catalog, and then that, or you create a new branch for each use case. So basically, I'll create a branch for today. We validate it at the end of the day, and then basically at the end of the day, you're always merging that validated data back into production. And then other uses, if you're going to do more branches, usually other use cases would be like, hey, I'm just creating a branch just for experimentation purposes, or I'm creating a branch to isolate some particular changes that I don't plan on merging in, but I want to kind of keep this separated. But generally, as far as like merging in, right now, you probably would prefer to keep it sort of make a branch, merge it in. Part of what's evolving in the project is kind of adding more metadata at that at what the catalog tracks, so that way later on you can have more sophisticated sort of merge resolution. But right now, best practice would be sort of like make an ingestion, have like a branch that is your ingestion branch and keep it that way, and then merge it and then create another branch for the next ingestion job after that ingestion job is completed.
Digging more into Nessie specifically, you mentioned a little bit about some of the specifics of running, and I'm wondering if you can talk to the overall architecture and design of the Nessie project and some of the ways that it has changed and evolved in scope and purpose from when it was first started.
Yeah, I mean, I think when it first started, it was, and I think it still wants to. It's still in this regard of being sort of a Lakehouse catalog. So while it mainly works with Apache Iceberg, it has the architecture so that it can expand in a sense, because basically what happens is that there's all these different types of things it can track, and then there's it's essentially just deciding on an agreed schema that's built into or built-in types. So right now, like the types are like namespace. So if you're creating like a subfolder or like a database, however you want to think of these namespaces. There's Iceberg views, Iceberg tables. There's also Delta Lake tables that are actually part of the spec right now. And they did try to make, there was a pull request made to the Delta Lake repository to kind of have that functionality, but that pull request never got merged in. So that is a to be seen in the future to see if we can eventually get that change made. But I mean, for like a format like a Delta Lake or a Hoodie, most of the time the table is just a particular directory. So it could just be as easy as just having a schema that's just basically Hoodie table, Delta Lake table that just points to a directory, and then it could catalog those as well. It doesn't now, but it wouldn't be hard to do because it has it's very flexible. It's just capturing this is the type of metadata that this little object tracks, and then making sure that you have a metadata object attached to that matches the schema for that type. So Iceberg has a particular set of information that you would keep with it. But the way you interact with the catalog is through a REST API. Now, so you could always custom make these API calls, but there is a client in Java and then Python to directly interact with Nessie on top of the integrations that are already existing with a bunch of tools. But basically, the way there is a standard specification there is the open API spec on the Nessie documentation that holds the endpoints. Like I definitely spent a few days exploring that quite in depth because I made like an unofficial client just to kind of get more acquainted with it, and that was a fun adventure. But it's a pretty straightforward API.
Are you sick and tired of salesy data conferences? You know, the ones run by large tech companies and cloud vendors? Well, so am I, and that's why I started Data Council, the best vendor-neutral, no BS data conference around. I'm Pete Soderling, and I'd like to personally invite you to Austin this March 26th to 28th, where I'll play host to hundreds of attendees, 100 plus top speakers, and dozens of hot startups on the cutting edge of data science, engineering, and AI. The community that attends Data Council are some of the smartest founders, data scientists, lead engineers, CTOs, heads of data, investors, and community organizers who are all working together to build the future of data and AI. And as a listener to the Data Engineering Podcast, you can join us. Get a special discount off tickets by using the promo code DEPOD20. That's DEPOD20. I guarantee that you'll be inspired by the folks at the event, and I can't wait to see you there.
Another interesting aspect of this project, going back to its nature as a catalog, is that the overall space of data catalogs for data lake environments has largely been a pretty static target of you have the Hive catalog, or you have the Hive catalog maybe in the form of AWS Glue, which is actually still just the Hive catalog. And I'm curious, in the work of building and evolving Nessie, using it as an alternative catalog to that Hive ecosystem, some of the ways that you have been constrained from innovating a lot in terms of what the catalog can offer and how to operate with it, and some of the ways that you're able to try to move the entire ecosystem along a bit to understanding some of the new ways that the catalog can and should be thought of in this data lakehouse ecosystem, and maybe some of the arbitrary limitations that the Hive catalog API has imposed upon us till now.
Yeah, I mean, I think a lot of the solutions to that particular problem were more repaired on the table format side. So essentially, like Iceberg really kind of broke away from sort of like the constraints of of Hive, where you have to kind of have folders and subfolders that define your table. And then Nessie is able to leverage that by being able to just refer to that table metadata and just focusing on capturing the versions of that. So basically, it almost takes a whole different paradigm of what the catalog does, that instead of it being the bearer of the metadata, but instead of it being sort of the gatekeeper of where the metadata is. So basically, where Hive, you have the Hive metastore that kind of acts as both your catalog and metastore. Nessie basically acts as the catalog, and then Iceberg will then be sort of really where the metadata is stored on your S3 in those manifests and manifest lists. And in that case, you can much easier incorporate future formats and new paradigms to the catalog. So I don't think it's necessarily been constrained. It's just a matter of like people choosing to adopt Nessie. That's become a lot easier in recent times, particularly just because it's like now that it's integrated into Dremio, a lot of people are just using it because it's once you have a Dremio Lakehouse, it just kind of is there. So it's there. So why not use it? And then you don't have to stand up the servers, you don't have to maintain it. So it makes the whole process a lot easier. But there's still also a lot of people who just deploy Nessie on their own and are just using it that way because they prefer to have that service that they manage on their own. They want to use a different backing store. They just want to have control over it. So we have seen a lot of adoption on that side too, especially over again, this last year has definitely been a big year as far as seeing growing adoption for Nessie.
For that integration process or running it yourself, what are the steps involved in actually getting it deployed, getting it integrated into a data stack, and maybe some of the complexities that people should be planning for, especially if they have an existing catalog that they want to migrate away from?
I guess the first step as far as deployment goes, I mean, if you just want to try it out, there's a Docker container, and that's pretty straightforward to use. If you want to deploy it for production, there is a Helm chart, so you can deploy that pretty easily using the Kubernetes Helm chart. And then just very soon, there'll be an iteration of the Dremio Helm chart that also should incorporate a lot of those details, so that way you can simultaneously deploy them easily. But once you actually have it deployed, as far as like migration goes, it just depends on sort of what your use case is. So basically, the assumption would be, hey, you're probably using Apache Iceberg or going to Apache Iceberg. So if you're already using Apache Iceberg before you adopted Nessie, the question then becomes, what is your prior existing catalog? So regardless of which catalog it is, what happens actually part of the Nessie project, they came out with a CLI tool for catalog migration, which is not just for Nessie, but for any Iceberg catalog. So you would just put in the credentials for the source catalog, and then you put in the credentials for the destination catalog, and what it does, it'll move all the references over. So then that catalog will have all the metadata references basically in one fell swoop. The only challenge there always becomes well, not really a challenge there. Like there, that should work fine. It's always like issues like there's the catalog, because the actual query engine has to have access to the catalog and then separately have access to the storage where the actual metadata is stored. So where an accident can happen is that, you decide you are using an engine that doesn't read, your files are in Hadoop. You just do a blanket migration of catalogs, but now you're using a tool that can't read Hadoop file storage. So now you still can't read those tables, even though you can read the catalog. So you definitely have to kind of keep in mind that you always have to think about, hey, does the tool have access to the catalog and the storage? But as long as you keep those two in check, usually you shouldn't really run into any problems, because essentially the query engine's path is check with the catalog, then check the storage. As long as it can do both, you're going to be able to read those tables just fine, assuming it adopts the Iceberg spec. Now, if you're not using Iceberg, then you're probably not using Nessie, so it's less of a consideration there.
In terms of Iceberg itself, that also provides a moving target because it's a very active project. A lot of different engines are adopting it. It has been growing in terms of its overall capabilities and usage, and I'm curious how that has influenced the direction and development of Nessie and some of the ways that Nessie has been able to capitalize on the newer features in Iceberg.
Basically, Nessie just operates as a way to discover the table. So in that case, it's independent of what's in the metadata. All it cares about is the location. Right now, it only cares about the location of that metadata.json. So what's inside the metadata.json, what's inside the other metadata files. So as we start adding things like delete files, puffin files, whatnot to the Iceberg specification, and in the future, other files, I think there's all sorts of other things that are sort of in discussion right now. All of that would not affect the way Nessie operates, since it's only versioning the references and not versioning the actual metadata itself right now. Again, in the future, it'll probably start holding more of the metadata, so that way it can do those more sophisticated merges and be more context aware of the tables. But the kind of data that it's probably going to need to track to do that is probably not the kind of stuff that's changing right now. Because we're talking about like, okay, what are the files that got added? What are the files that were subtracted? It doesn't necessarily have to track like every single thing that the Iceberg metadata does, just what it needs to be aware of, not tripping up when it's merging.
And then another responsibility that can often get pushed into the catalog layer is the question of access control or permissioning. And I'm curious how Nessie handles that aspect of the problem space.
Yeah, there's two ways you can handle that right now. Essentially, you can have different users that are accessing the Nessie catalog, and essentially the access controls are applied to like the user. So basically, if I access the catalog with a particular token, well, basically it'll be aware of, hey, this person using this particular access token can only access these branches, these objects, these kind of things. So you can do that manually with Nessie, and there's ways of sort of configuring a lot of that. That's still probably requires like a lot of manual configuration. When you're using Nessie as it's integrated into Dremio, then it falls into Dremio's more point and click type of authorization, where you can basically have role-based access controls, row-based access controls, column-based access controls at the query engine layer. So basically, it'll leverage some of like Nessie's branch level controls, and then also leverage Dremio's query engine level controls when you give different users tokens from different tools.
Once Nessie is part of a given data stack, the versioning and branching and merging capabilities are part of the core primitives of the system. How have you seen that influence the overall workflow and design approach that teams take as far as the development, deployment, evolution of their data processing and data delivery flows?
It basically goes pretty simple, because oftentimes, like again, the pattern I've seen most was the pattern I mentioned earlier, where people just do a daily branch. So basically, all you do is you just tweak all your jobs to just hit that particular branch. And since you have like a naming scheme, so you basically it'll be like, branch, whatever you want to call the branch, and then like maybe a timestamp or a date. Basically, it's pretty easy to programmatically set up your pipeline. So always make sure that they're targeting the right branch name. So then you can just kind of run the branch. It'll always hit that day's branch. And then basically everything becomes very turnkey, but like midday, you're not going to see suddenly like your production data getting tainted, because it goes through that daily process. And then systems that need to access that data like real time, they have access to that branch. So they'll query that branch directly without the same sort of guarantees you would get with the production branch, and that'd be sort of clearly communicated. But yes, usually it, because once you have it, basically the actual creation and merging of branches is pretty straightforward enough to do in SQL, and then automating that SQL with whatever, whether it's Spark, Flink, or Dremio, is pretty easy. So once it's basically just kind of deciding what is the frequency of their branching patterns. Do they want to do hourly branches, daily branches, weekly branches, and what their merge cadence is going to be. But once they kind of figure that out, once it's implemented, you don't really think about it anymore. It just kind of works.
Another common target for operating with this data is something like a DBT, and you mentioned the zero copy clones, effectively, of being able to create per user branches. I'm curious how you've seen folks incorporate Nessie's versioning and branching capabilities into the development workflow of DBT users and data analysts.
I've seen it with DBT users, because Dremio does work with, again, any tool works with DBT, but basically in the SQL, you can specify the branch in your query. So you can just sit there. So I've seen it personally, I've seen it with Dremio. And then basically you can just sit there and just add branch at the end of each of your queries. and then you get all the benefits of DBT and all the orchestration and using Git version control on your DBT models. But then you also get this other layer of versioning at the catalog level, so you get to leverage both and get the benefits of both.
In your experience of working with Nessie, exploring its ecosystem, diving deep into the Iceberg table format and the ways that the two interoperate, what are some of the most interesting or innovative or unexpected ways that you've seen the Nessie project applied?
There was one. I'm trying to remember what the exact details were, but I've seen some interesting applications of just creating a branch for like they're not just to kind of create wildly different versions of a data. Like actually, one example with still using that day pattern that I mentioned before, but also what they'll do is they'll create experimental branches, because these are like generally like large financial institutions who we've seen this pattern with. And what they'll do is they'll create a branch that they use for doing like stress testing type whatnot. Because what they can do is that they can create a safe copy of their production data for that day to then make the changes to that data that they don't want to permanently make to then run all their stress testing calculations on. And then they can just throw away the branch at the end of the day without having to really worry about rolling it back or undoing the data. So they just make a branch at the beginning of the day that's for like stress testing, add in the, hey, bad scenario here, worst case scenario there, and then run their tests, and then they can dispose of it every day.
In your experience of exploring this space, keeping up to date with the use cases, the technologies behind it, what are some of the most interesting or unexpected or challenging lessons that you've learned?
I mean, oftentimes I think where it's always going to be sort of like the great thing about the Lakehouse is that everything's very modular. So you can kind of swap out the different pieces you want, but there's still like little gotchas, particularly in sort of like, as I mentioned earlier, when you're working with any catalog in the Iceberg space, there's two layers. So you have to make sure that you have the authentication to access the catalog, and you have the authentication to access the storage. And different tools have different stories when it comes to both of those layers. And that's oftentimes where a lot of gotchas kind of come in. So I always just say, hey, doing the legwork to make sure that, when you're working with a catalog, making sure that the tools you use can read the catalog and then also access the storage, because that can definitely bite people in the butt where they're working with something that they like, but then they move to X tool. And then now, they were using, let's say, X object storage, and now that particular storage layer isn't readable by that tool, so it kind of interferes with their plans, even though it could interact with Nessie or some other catalog.
And for people who are interested in these versioning capabilities, what are the cases where Nessie is the wrong choice, and maybe you're better served by just using an AWS Glue, or maybe just not even using Iceberg at all?
Basically, if you're using Iceberg, I think Nessie is a good option. Now, the reasons you would not use, you might choose AWS Glue would oftentimes be because you're really inside the AWS ecosystem. So if you're connecting to Athena, you're connecting to Redshift, you're connecting to all these tools, then AWS Glue is going to be a very easy sell because it's going to have that interactivity. But if you're operating multi-cloud or in a completely different cloud, that's not necessarily going to be the same, have the same saliency. But if you're not even using Iceberg at all, like you're using Delta Lake or Hoodie, then oftentimes like different solutions might work better. Like generally with the only option, it would be like Lakehouse. You only have file level versioning available at the moment, which again, I always think of it as like another feather in the cap for Iceberg. Not only does it have the rich ecosystem of things that can write to it, read to it, manage tables, but you also have a rich options of how you can version control your tables, whether it's file versioning, table level versioning, or catalog level versioning. Iceberg really gives you a lot of options to kind of really architect the Lakehouse you need.
Have you ever seen where people are using both LakeFS and Nessie in tandem?
I don't think I've seen it yet. I've seen one or the other. Theoretically, they can work together. I mean, it could be like basically one of the issues like LakeFS has with like Iceberg in particular is that Iceberg really depends on absolute paths, and LakeFS depends on relative paths. So LakeFS had to create their own custom catalog. Always the problem with the custom catalog, though, is engine support. So it works with like Spark or Flink, but then you get to many other engines, you have trouble connecting that catalog. So I could see a world where basically someone is working with multiple formats. They may be working with a Delta Lake and an Iceberg, and they might want to use Nessie for Iceberg, but they want to use LakeFS for Delta Lake. And I can see that. And I mean, I can see different situations where you're working with data that's outside of a table that you're going to want to roll back, whether it's like, a group of CSV files. In that case, like LakeFS would be helpful. But again, when it comes to your main Lakehouse catalog, you might prefer a Nessie to provide those kind of semantics. So I can see a world where all three levels have benefits, because even at the table level with Iceberg, a nice thing about being able to tag tables in Iceberg is that it prevents them from being cleaned up when you do cleanup operations. So if I tag like an end of month snapshot, then when I expire snapshots, it won't clean up those tag snapshots. I mean, the same story when you tag commits in the catalog level. But again, there's going to be different situations where you might want each of these levers to be available to you. So I haven't seen it too much yet because I just feel like I'm still seeing I'm just starting to see people start adopting these kind of patterns, at least on the Lakehouse level. And then also like this sort of Git style delivery of them. But I'm starting to see it more and more adopted, but it's still sort of very early days.
For people who are interested in Nessie and want to keep abreast of its development, its future direction, what are some of the things that are planned for the near to medium term, or anything that you're keeping an eye on or you're excited to see come to fruition?
I guess my wish list is going to be like Apache Iceberg support for Nessie. That's definitely high on my wish list. I tried to make that contribution. I started like writing some of the pull requests, but I then ended up just not having the time that I would have liked. So if anybody wants to help contribute that, please go join over there. There's a lot of great work to do there, and there's a lot of really great devs working over there on Nessie that you can communicate directly with them on the Nessie Zulip. So Nessie uses, instead of Slack, it uses Zulip, which is like the open source Slack. So you can communicate there. So there you can like participate in the conversation about the evolution of the format, not the format of the catalog and its future features. But I would say like my short-term wish list would be Apache Iceberg support. One of the cool things I keep hearing about long run is going to be, again, that sort of more context awareness. So and then also would be really cool is that eventually, the pull request can get accepted over there at Databricks. So that way, Delta Lake to be able to support Delta Lake and Nessie or something like that, to just offer more options. So that way it can become, ideally, you have a catalog, you can hold all the things. But it's a pretty cool tool, and the patterns I'm seeing with it are pretty fun. And then I think what's most unique about it is just sort of when you start doing the SQL for it and you're seeing how easy it is to do it. Yeah, to me, that's when I was like, okay, this is nice. This is just easy and simple to use, that it really does make a lot of new patterns a lot easier to execute.
Are there any other aspects of the Nessie project, the overall kind of use cases or capabilities of data versioning in the Lakehouse that we didn't discuss yet that you'd like to cover before we close out the show?
I guess a couple other use cases that I think are implied, but just to make them explicit, are like multi-table transactions. And one thing I think, like right now, they have introduced like multi-table transactions at the table level versioning in the table level in Iceberg. But the way it's done is you have to use a catalog that supports REST catalog, and they have to kind of implement this multi-table transactions. And it's more like a traditional sort of begin end transaction type style, where basically you have to kind of do everything at one time. The nice thing about the Git style, which you get with like Nessie or Lakehouse, since they're both taking that sort of Git-like approach, is that I can create a branch, and I can do multiple transactions, and none of those transactions are published until I do a merge. So I could be doing one transaction on one table in Spark, another transaction on another table in Flink, another transaction, another table from Trino or Dremio. And then once all those transactions are done, all those transactions can be published simultaneously to all those tables through one merge. And that's sort of a unique form that just doesn't actually currently exist in a data warehouse at all. So that's a really neat thought process, because I do think it opens up some new ways that you think about how you do those transactions across multiple tables and work with multiple table semantics.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Basically, my opinion is going to be something to tie it all together, and that's kind of why I find working at Dremio really exciting, because we do have a tool that's really trying to tie things like Iceberg, Nessie, all these different data sources, and tie it together in sort of one cohesive platform where it feels like you're getting that modular system, but it comes with like the ease of use and nice sort of flavor that you get with like a more integrated system like a Snowflake, but you get that ease of use in a more deconstructed system on the Lakehouse. And I think that has been the thing that people have been really looking for. And I do feel like we are or on the verge of really kind of providing the solution to that. So if that's a pain you're feeling, definitely come talk to me.
All right. Well, thank you very much for taking the time today to join me and share your perspective and your experiences working with Nessie and helping us understand the problems that it solves and how to incorporate it into a data lake environment. It's definitely a very cool project. It's great to see more investment and evolution of this data versioning capability in the data processing ecosystem. So appreciate the time and energy you're putting into that, and I hope you enjoy the rest of your day.
Thank you very much. It was a pleasure.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.